We will divide the screen into 4 areas. Here, we will generate 225 random numbers. Here we will build the frequency table. We will plot the frequency distribution in this chart. In this area, we will plot the cumulative distribution. Let's briefly discuss the parameters on the screen. The number of classes is the number of categories into which we will divide the random data. The number of classes chosen is largely subjective. It should be small enough to properly summarize the data and large enough so not to lose relevant details. The class size is determined by a calculation we will discuss momentarily. The class boundaries are the low and the high values of each class. The midpoints are the middle values of each class. The frequency is the number of data values that occur between the low and the high boundaries of the corresponding class. Each relative frequency is the portion of data values that occur between the low and the high boundaries of each class. The cumulative frequency is a running total of the frequency. The relative cumulative frequency is a running total of the relative frequency. Each of the elements of the frequency table will be discussed in greater detail as we build the frequency table. We will now generate the 225 random numbers of our dataset. Let's note the maximum value in the dataset is 50, and the minimum value is 1. We will be making use of these values when we calculate the class size. Now we select the number of classes into which we will divide the data. We decide on 10. We feel 10 classes will adequately summarize the data and still provide enough detail. The next step is to calculate the class size using the following equation. The class size is determined by subtracting the minimum value in the dataset from the maximum, divided by the number of classes, and always rounding up to the next integer. The maximum data value is 50, minus the minimum value of 1, divided by 10 for a result of 4.9, rounded up to 5, which is stored in this location. The next step is to determine the class boundaries. A crucial element in building a meaningful frequency table is to correctly determine the class boundaries. If done incorrectly, the other elements of the table will not properly reflect the data and lead to erroneous conclusions about the data set. Determining the class limits is an intermediate step in calculating the class boundaries. The minimum value of the data set determines the value of the low limit of the first class. The low limit of the first class plus the class size determines the low limit of the second class, 6 for this data set. It then follows that the low limit of the second class plus the class size will determine the value of the low limit of the third class, 11. The remaining limits are determined in the same way, by adding the class size to the preceding class's low limit. The class size determines the high limit of the first class. The class size plus the high limit of the first class is the value of the high limit of the second class. The remaining high limits are determined by adding the class size to the preceding high limit, until we have a high limit for all 10 classes. Notice the high limit of any class is always 1 less than the low limit of the next class, leaving a gap of 1. This gap is eliminated by subtracting 0.5 from the low limits and adding 0.5 to the high limits, and rename them class boundaries. The midpoints are, as the name implies, the point in the middle of the respective class. The midpoint between 0.5 and 5.5 is 3. It follows then 8 is the midpoint of the second class, that is, midway between 5.5 and 10.5. The remaining points are determined the same way. The frequency is a count of the number of data values that fall between the low and the high boundaries of the respective class. We start the count at 0 for the first class. Then count the number of times there is a value between 0.5 and 5.5, and note a total of 23 for the first class. Note that the count for the cumulative frequency is also 23. Here we started plotting the frequency distribution, and here the cumulative distribution. The first rectangle in the frequency distribution chart represents the frequency of the first class. Its height is equal to 23. the frequency of the first class. The width corresponds to the class width of 5 calculated earlier. Note the left side is set to the value of the low class boundary, and the right side is set to the value of the high class boundary. The cumulative frequency of the first class has a value of 23, which is the same as the frequency, and uses the same low and high class boundaries as the frequency distribution chart. The difference between the frequency and the cumulative frequency will become apparent as we fill in the rest of the table. The frequency count for the second class also starts at 0, but the count for the cumulative frequency of the second class starts at the count for the frequency of the first class. After counting the frequency for the second class, it is determined to be 19. The cumulative frequency of the second class is 42, which is the sum of the frequencies of the first and second class. This procedure is carried out until we have a frequency and cumulative frequency for each class. Note the sum of all the frequencies is 225, which is the total number of values in our data set, and the cumulative frequency of the last class. The relative frequency is the fraction of data in the corresponding class and is calculated by dividing the frequency by the total number of values in the data set. Therefore, for the first class, it would be 23, divided by 225 for a result of 0.102. The relative frequency of the second class is divided by 225 for a result of 0.084. The remaining relative frequencies are calculated in the same way, and that is to divide each frequency by the total number of values in the data set. In a way similar to the relative frequency, the cumulative frequency is determined by dividing the cumulative frequency, 23 for the first class, by the total number of values in the dataset, 225, for a result of 0.102. The remaining values for the relative cumulative frequency are calculated in a similar way until we have a relative cumulative frequency for each class. Let's note that the sum of the relative frequencies is 1, and is always 1 for all data sets. We should also note that the relative cumulative frequencies have a maximum value of 1. A complete discussion of these properties and how to interpret the frequency and cumulative distribution is given in the Math Concept Kernel Histogram Observations.